Let me show you how we can create real-time renders like this directly from a 3D model using AI. I will use a model from Rhino, but you can use any 3D model you want to. And then we will learn how we can create this workflow using Stable Diffusion and ComfyUI and use our 3D model directly in real time. I will also share a custom script to install Stable Diffusion on a cloud server, so you can use it even if you don't have a computer. It is going to be a slightly longer video because I wanted to share all the details, but you can find the timelines in the video descriptions, so feel free to skip the parts you want to watch. Let's start. So for this workflow, I will try to render this model, and this is Polyplaza project from China. The script was created by Decoded Facades. Thank you for sharing the scripts with me for this model. He's sharing most of the famous parametric designed buildings, or maybe just their facades and how we can recreate them. Not just the models, but he also tries to explain what is the logic behind this parametric model. So if you're into these topics, definitely go and check this page out. You can use any type of view in your computer screen. It can be either from a Rhino in this case, from a SketchUp model, or from ArchiCAD, Revit. Basically any model will work with this workflow. I'm gonna use ComfyUI on RunPod instead of using on my own computer, just to make the process faster. And also I want to show you how you can set up ComfyUI on RunPod. If you cannot use it on your own computer for some reason, you can easily do it here. First, of course, you have to go sign up for the RunPod platform. You can find the link in the video description. After you sign up, this is a paid platform. Basically you pay per hour of usage, but it doesn't cost much. So you need to go to your wallet and then deposit some money in your account. You can deposit as low as $10, and after you do that, you can go to pods, click on new pod. Here we see all of the GPUs that are available for us to rent. We have two options, Secure Cloud and the Community Cloud. We can choose both of them. Community Cloud is a bit cheaper compared to this one, so I will go with this, and then make sure the speed is choose Extreme. You can choose any GPU that you see in this menu, but most of the time I use either RTX 4090 or RTX 3090. I think this one is a really nice one for performance and the price. It costs 26 cents per hour, so I will go with this one. In this menu we have to click this part and change storage we want to use. I prepared a script that you can install ComfyUI and all the models, extensions, ControlNet models, IP adapter models that you will need. And to install everything we need around 200 gigabytes. But just to be safer, you can type 300, and this doesn't cost much. For the ports, we have 3001 and this one for the default. These are probably enough, but just if you want to use maybe two different ComfyUIs at the same time, or for some reason we cannot connect to this one, that's why let's add also 3002, 3003, 3004, just so like we will have place if we have any issues. If this doesn't make any sense right now, it's fine. You just need to add these ones here as well, and then set overrides. And for the template we will use this one, RunPod Fast Stable Diffusion template. You can just type fast and it will appear. There is also this ComfyUI template directly within RunPod. For some reason, for some extensions is not working in this one. That's why I prefer using this one and install the ComfyUI and all the models myself. And then continue, deploy. This will just take a couple of seconds to activate the GPU. And if you come to my pods, you can see now it's starting. And once it is ready, we will see this connect button available. It is running, you can go and connect. Choose connect to Jupyter Lab option, and then a Jupyter notebook will open. And I have prepared these two scripts so we can install ComfyUI and then download all the models, extensions that we want to use. So just drop them here onto the File menu. Go ahead and open a terminal. To start the process, you need to copy and paste this script here. I will share all of these files and the scripts in the description down below. So after you paste it, just click enter. This will install all the necessary libraries and the ComfyUI, the models, checkpoints, ControlNet, basically everything. That's why it's gonna take some time, depending on the internet connection of the GPU we connected. And once we see this installation is done, enjoy text at the end of the terminal, that means it is done. You can open a new tab from here, and then let's open another terminal. And this time, to actually run the ComfyUI, you need to copy and paste this script and then enter. The first part you need to do only once once you open a new pod. But if you already have a pod that installed, then you don't need to wait all the time, like around 30 minutes, 1 hour. You can just start the ComfyUI directly. Sometimes you might need to paste the code a couple of times to get it right, but eventually it will work. And while it is downloading, we can check which models we are going to use for the real-time render. This is the main model, Stability AI published, called SDXL Turbo Vision XL model, Reality's Edge, Ultra Spice, Realistic Vision Turbo model, which is one of the most popular ones. I will also test this. If you want to add a new model that is not here, for example, let's say this one, click on this file and we have this download link here, but instead of directly clicking on it, right click and copy link address. And then we need to go and install it into the correct folder, which is inside the ComfyUI, and then the models and checkpoints folder. I don't know really why, but maybe there are lots of files inside checkpoints. For some reason, I cannot go inside checkpoints folder in Jupyter Notebook. So that's why what we can do is you can right click and copy path first, and then to move there we can type cd/ and then paste the address. So now, as we can see, we are inside the checkpoints folder. Let's go and copy the address again, and we can use wget command. Wget, you can place the link between these quotation marks, and then we want to rename the file automatically. So to do that, you can type -o, and let's copy this name. So you can type turbo.savetensors, which is the file extension, as we can see here, and then enter. And you can see the progress in this part, and it will be saved as what we named in this part. But for most of the models, you don't need to do this, because I already installed many models, and we can check this by going to the checkpoints folder again, and if you type ls, we can see all of the ones we installed. So let's go back to our original terminal where we started the ComfyUI. So if you see this message at the end of the terminal, it means the ComfyUI is started and it is active. But since it is not locally running, we cannot just click to this link. We need to go back to my pods, open this part and click on connect. Since we started on 3001 port, we need to connect this one. And if you click, we will see the ComfyUI is running. So this is the default workflow. You see when you open the first time the ComfyUI. If we check, these are all of the models we downloaded, and let's just test it once, make sure it is working. We get our image. So I have already prepared the workflow for this real-time render. I will directly place it here, and then I will try to explain on top of that one. And if you don't know, if you have an image that you generated inside ComfyUI and you want to use the same workflow with that image and the same parameters, the same settings, everything, you can just hold the image and leave it into your canvas. Then you will get all the workflow like this. So you can directly change the base image or the prompt and then use it yourself. Right now we have all the extensions, all the custom nodes installed correctly. That's why we don't get any red errors about the missing nodes. But if you see an error like this, then all we need to do is go to manager. In this manager, we have many options to install a new custom node, install the missing custom nodes, or install the models. This one is really handy because when you get a new workflow, probably you don't know which nodes is used inside. So you don't know the names also. But if you click on this one, the manager will directly say, okay, this workflow is using these custom nodes, but you don't have these ones, and it will list them here. For now, I don't have any missing ones, but if you do, they will appear like this in this table, and you can just click on install. After the installation is done, you can restart the ComfyUI and then refresh the page. Then it should appear. Sometimes it cannot get the right version in the first time. So if you still see the missing custom nodes after the first one, just go back to manager, go back here and install it one more time. Then it should work. It is not really a super long, super complex workflow, but one of the nodes is new and it is the more exciting ones, which is this one. It's called screen share from MixLab nodes. Normally, as you know, for ControlNet, and this part is for the ControlNet, we need to feed an image. Normally, we are doing this by using this load image component, and you can just choose an image from here, upload an image, and then we can connect it to the ControlNet. But in this one, what we are doing is, instead of loading an image, we want to get a view from our 3D model, which is Rhino in this case. We have a couple of options to choose. First, you can share screen. If you want, you can also direct get view from your camera, so from your computer's webcam. I will choose share screen. And you can either choose a specific tab, like normally you are sharing your screen in a meeting, or you can choose a specific window or your entire screen. In this case, I think choosing a window makes more sense. So you can fix it to the Rhino. So even if you change your screen, it will not change the view. Pop-up shows, we are right now sharing our screen. Just say hide. Now we see our entire Rhino window for here, but we don't care about this part. We only want to see our 3D model. That's why I will click on set area, and then we can specify which part we want to get. Let's choose something like this, or maybe if we choose something more square, it will be better. So something like this. So right now we are only capturing this part. After we captured this part, I'm using this image resize component, which you can find by typing resize and this one. What is happening in this part is I want to resize the image before feeding to the ControlNet, because for 1.5 models, the default size is 512 pixels. And right now I'm going to use the XL model, turbo model. So the default size is 1024 pixel. If you feed a super large image, you will get weird results like these ones. And also if you feed a really small image, it will not also perform really well. So just to automate this process, I'm doing this resize, and I set the smaller size is 1024. So it will adjust the other larger side according to this aspect ratio. And from this resize mode, you can choose any option. So if it's smaller, it will make it bigger. If it's bigger, it's gonna make it smaller. And if you go to the beginning From this load checkpoint node, we can choose which checkpoint model, so which AI model basically we want to use. Let's start with the base model, which is Stable Diffusion XL Turbo, this one. And we have two text box basically for our prompt. And this one is for the positive prompt right now. If you want to make it more obvious, we can change the color to green, for example. And this one is for the negative one. We can change this color to red. But for turbo models, negative prompt is not working. So even if you type something for the negative prompt during the generation, this negative prompt will not be taken into the consideration. So this will be just empty for now. Normally, if you are not using ControlNet, this is the whole process, but we want to feed our model. That's why we have this additional ControlNet part. For this 3D model, I think the depth one makes more sense. That's why I'm using this ControlNet XL models, the depth one. As you can see, we install many different ControlNet models for both 1.5 and XL models directly. So you can try different ones and see which one performs better. I have initially set this as Midas depth map, but now we have a new one, which is, I think, working better. Depth anything. So let's change this one to this depth anything, and we can see both of them, how it performs. And then we have apply ControlNet, where we are feeding our positive prompt first to the ControlNet here. So basically from here to this one, and then it is going back to KSampler. For the latent image, we are using an empty latent image component, and normally this one is looking like this. We can change the image width and height from these bars, but I want to automate this one as well. So to do this, you can right click and convert the width and height to input. So instead of playing with this bar here, it becomes an input that we can feed a number automatically, and also for the height. And I'm using this get image size component to do this. So if you type get image size, we can feed our resized image directly to this component, and then connect this ones to width and height. So we will directly generate the same image size as our input. I will delete these ones because I already have here. And the biggest difference for the turbo models is the number of steps. As you may know, normally a good range for the step is around 20, 30 to 40 steps, depending on the sampler and the models. But for this one, technically, you can even generate a nice image with only 2 or 3 steps. Let's go with 3. But of course, if you use something higher, around like 8, the quality tends to be better. So let's go with 4 for the first one. And for the CFG, normally around 8, 10, 12 is a good number. But for turbo model, you need to keep the CFG scale a bit lower. So around 2, 3, even 1.5 maybe. So I will just organize my view a bit better. Something like this maybe, and we can see automatically how it's adjusting in this part. And maybe I will change the view to render. Okay, I think it's a good starting point. In our prompt, we have raw photo, parametric building in the city, fall, late afternoon, sky, living gray, night quality, etc. So let's just hit generate and see what we have. I will test both of the depth maps to see which one gives better results, and then we can remove one of them. Because for the ControlNet and Stable Diffusion, this image we are feeding, so this image we are feeding to Stable Diffusion, it doesn't mean anything. We are not using this image directly. We are using the depth ControlNet. The only important image is this one in this case. So this should be a nicer one if you want to get all the details. As you can see right now, the details on top of the model like these elements and the vertical frames for the windows are almost totally missing. So probably we will not get a super detailed image, but we can fix this later. And we get an image like this for the first time, which is not really a nice one. Let's try another depth map, the latest one, and maybe increase the step number. Let's see how this one will perform. We can see the frames a bit better, but still it's not super nice. So, and the image is not super nice. Let's try a better turbo models. For example, Turbo Vision XL, the new version, and see how this one will perform. And after we find nice settings and the nice parameters for our model, and then we can go to the real-time render process. This one is much better, is somewhat getting there. Let's increase the steps number a bit more. We found a better settings and parameters right now. I didn't change much settings. We are using right now 4 steps and this latest step map, which is quite nice in this case, captures most of the details compared to other ones. So I will erase the other ones and only have this one. And for the prompt, it's kind of same, but I only added single tower building. We can set the seed for increment and keep testing some different options. Sometimes it tends to put another building next to it. I'm not really sure why it does this. To have a better control and maybe more accuracy from the prompt, we can add another ControlNet and combine both of them. Right now we are using this depth model. What we can do is try to get edges of the model, so we have more details and more information about these small details on top of the building. So I will just copy this apply ControlNet and load ControlNet model. But for this time, instead of depth, I will choose Kenny. Let's get a Kenny preprocessor and I will feed our image here. Then let's copy the image preview as well and feed the image here. Now, instead of directly feeding this conditioning to the positive prompt to KSampler, first we will feed it to the second ControlNet and then we will connect this one to this one. So first from the positive prompt, we are going to first ControlNet to depth one. And then from here, we are going to second one to the Kenny. And then we are connecting back to KSampler. Let me add a group here too, so it's more organized. Let's run it again. So now you see we are also feeding this information. And this is quite nice, but maybe we want to see more details even about these frames on the windows. So we have 2 threshold settings for the Kenny. If we lower these values, it will capture more details from the base image. And if we increase these ones, it will capture less details. That's the idea. So let's set up these ones to something like this. And if I run it again, you will see the difference in the image. As you can see, we have way more details and we want to capture these ones. Maybe we can even reduce it a bit more to 0.5 to 0.10. We solved this issue of adding another building next to it. This was the previous one, the new one. Let's run it again with even more details. So now I will add more details to the prompt about the building, and maybe let's remove the fall. White polycarbonate material, glass window with metal frames. Let's also remove this late afternoon, or let's keep it for now. Let's run it. So I'm happy with the workflow we can play with our prompt and get a better result, change the mood, etc. But now let's go and try to explore how we can play with our model inside Rhino and get instant views from the model. Right now it is not constantly updating from this view, so even if I update this part to something like this, if I don't run it, we don't see anything. To run it constantly and get the views all the time, we can click this live run option or open this extra options and open the auto queue button. Let's click on live run, and now even if we don't click queue prompt, it will automatically render all the time. So after we make some changes in our model, we can directly see the views here. But it might be hard to do this if you have one window. That's why there is a nice component that we can use, which is called floating video. Right now it is connected to save image, but we can also connect to this one. And if you click this picture in picture, now we have this floating window with a prompt. I want to copy our prompt here and place to this one. And let's now go back to Rhino. So now we can directly play with our model and get instant views to here. So ideally what we can do is change some prompts here, and then we will see the effect directly. And also really good thing is, since our model is from Grasshopper, we can directly play with the model inside Grasshopper and see the changes. I will keep the view stable like this for now and then try to change the prompt. Right now we are using 6 steps, that's why it's a bit more slower. And remember, we are not using a super high quality GPU, but if we increase the performance of the GPU and get a new one, you can do this way faster. But let's try to reduce the number of steps to 3, for example, and see how it will go. Now it is way faster, but the quality is not so nice, so I prefer waiting a bit more to get a better image. So let's try to use, for example, black material and change to dark night view. And if you want to make it more stable, not to change the image so much but slightly, we can try to change this seed to a fixed one, so we will always use the same seed number. Okay, I really like this image composition, how the background and the building itself, the reflections on the windows, see it as fixed right now. And now I will play with some of the changes, and maybe let's try to make this window frames, these white parts, a bit larger. Of course, because I moved the frame, the model, the view is also updated, but now it's back to a better position. We can reduce the number of this dividation, for example, have a larger window frames. And as we can see, this is a really nice way to see and imagine the building in different forms, because the form we adjusted it from the Grasshopper and the view directly changed, but the environment and the overall mood is almost the same. But we can see how changes in the building shape can affect the vibe and the mood of the final shape. For example, let's make them way dense, these frames and dividations on the facade, and see how it will look like. So right now we are only using this view as an input and our prompt. So from image to image we expect it to change more or less, but even without any additional settings it is still more or less similar vibe. So we can focus more on the changes on the building, but we can try to even improve it with using reference images. I will remove this one and I will open some space by moving these ones a bit, and we will use the reference images to do this with IP adapter node. So we need IP adapter model, and then I will feed the models and the clip vision model quickly. These ones are also coming directly with the installation script automatically, so you don't need to do anything else. We are using the XL model, so I will choose this IP adapter SDXL Safe Tensor one. There are some couple of options. These are for specific for person faces. These are the plus version, more or less similar results, so you can try and see different ones. Let's go with this one for now. Plus means it will have more effect on top of the final image. And of course, we need to feed our reference image and to connect it to the workflow. So right now, as you can see, this is not connected to anywhere. We need to feed the model first to IP adapter from our checkpoint. So instead of going to the case sampler directly, first we feed it to the model and then from the model back to case sampler. So right now it will also use this reference image, but right now it's using this one. I will find one of the nice images we get, for example, to use as a reference. Let's say this one. I will download this image. And then from here we can place to this part. So now we will use this image as a reference. So ideally the logic is even if you change the model shape or the model view by moving inside the Rhino, the end result is gonna be more or less similar to this image, so we will always have the same vibe. Maybe we can reduce the strength a bit so it's not super powerful. So even if you change the prompt a bit, it will still be somewhat similar. So now let's go back to Rhino model and have our window back. So maybe changing the parameters, we can try to move the model and see how it will change. I want to change and see how it will perform instead of the turbo model, but with the normal XH model, new reality XL model. And of course, then we need to change the step number to, let's say, 40, and CFG scale, let's change to 90. I will keep the same reference image for now. Now let's test this Ultra Spice one. I don't know how that one will perform, but let's see. And as we can see, that there is almost no quality difference for me if you don't look super carefully. And it's way faster, so this makes more sense, especially in this workflow. I want to try one more thing with this workflow. Right now, we are feeding as a reference image one of the generations, one of the images we just generated. But as you know, this is a real building that is built, Poly Plaza. So I want to get an image of the original building and then use it as a reference image. Maybe this way it will be closer to the actual building. Let's choose this one and we can save the image. So this is the image. Image size is really large, 2000 to 3000 pixel. I will resize it from this option, resize image, to let's reduce the height to 1000 pixel or maybe 1024 and save it. Now I will place it for the reference image and let's see how it will turn out like this. This is way closer and way nicer, I think, to the original design. Especially let's go and adjust the parameters a bit. So I think we covered most of the idea and what's going on in the workflow, how it is working, what is the logic behind it, and how we can capture a view from Rhino. As you can imagine, this doesn't need to be Rhino specifically. It can be any 3D modeling software or any type of other view that you can capture from your window, basically. It can be also video or it can be directly your webcam. So it is really flexible. Right now, we use the depth map and the Kenny edge map, but later on I turned off the depth map because even only with the Kenny it performs quite nice and this is way faster. Normally generate this depth map it takes some time, so you can either choose to use them together or use only Kenny. If you don't want to use a part like this, you can just choose all of them and press Ctrl B to turn it on or turn it off. And we have this part where we can set up a reference image. Basically, you can upload any type of image you want in this window and use it as a reference image. And you can play with the strength of this reference image in this bar. And that's all basically. And this is only one of the use cases for an exterior building view. This can be also super powerful with interior views to generate different layout options, to visualize different materials, different textures super quickly, directly inside the model. And here are the final images. So I hope you liked this video and this might be useful for you in your workflow. I will share all the resources including the RunPod installation script workflow that we created and also the 3D model that you can download and play on top. You can find the link in the video description and the resources will be available on my Patreon page. So if you want to just download the same ones and use them as it is, you can find them there, but otherwise feel free to create your own workflows as well. So I hope you liked it and see you in the next video.